Right now, this week, a spacecraft is closing in on an object that's been secretly tagging along with Earth since before the Roman Empire existed. It's not our moon. Most people have never heard of it. And there's growing evidence it's actually a piece of the moon, blasted into space by an impact millions of years ago, and quietly stalking our planet ever since. Its name is Kamoʻoalewa. It's smaller than most office buildings. Almost no telescope on Earth can actually see it. And yet a National Space Agency spent $1 billion mission chasing it down, because if the leading theory is right, it isn't a normal asteroid at all. By the end of this video, you'll know exactly what it is, why scientists think it came from the moon, and what's happening to it right now, this week. Here's the part almost every headline gets wrong: Kamoʻoalewa doesn't orbit Earth. Not really. It orbits the Sun, on almost exactly the same one-year path Earth takes. Because the two of them are moving around the Sun at nearly the same pace, and Kamoʻoalewa's path is tilted and stretched just slightly differently, it looks, from our point of view, like it's slowly looping around us. That's what quasi-moon means, not gravitationally captured like our real moon, just a travel companion that happens to be going the same way, at the same speed, forever almost catching up and falling behind. It's not attached to us. It's not going to crash into us. It's just going the same direction we are, close enough that we noticed. Think of it like a car drifting alongside you on the highway for hundreds of miles, not because it's attached to your bumper, but because it happens to be going your speed, your direction, for a very long stretch of road. Eventually one of you will pull ahead, or fall back. For Kamoʻoalewa, that eventually is measured in centuries, not miles. So how did anyone even notice a building-sized rock quietly matching Earth's orbit? By accident, in 2016, and almost missed it. In 2016, the Pan-STARRS survey telescope on Haleakala spotted a faint point of light drifting in a strange loop near Earth. It got a Hawaiian name, Kamoʻoalewa, roughly translating to the oscillating celestial object, which is a remarkably accurate description for something that just wobbles back and forth near us forever. It's small. Somewhere between 40 and 100 meters across, closer to the size of a large building than a world. And it spins fast, once every 28 minutes or so, tumbling through space. Pan-STARRS wasn't even looking for something like this specifically. It's a survey built to scan the sky for anything that might one day threaten Earth, cataloging thousands of near-Earth objects almost as a byproduct of just watching the sky carefully, night after night. Kamoʻoalewa could easily have been filed away as one more forgettable dot in that catalog, too small, too faint, too ordinary to warrant a second look. For years, that's basically what happened. Then people started looking closer at what it's actually made of, and ordinary stopped being the right word. So far, a small rock, looping near Earth, discovered almost by accident. Harmless. Forgettable. Except for one detail that changed everything scientists thought they knew about it. When astronomers measured the light bouncing off Kamoʻoalewa's surface, its spectrum, it didn't look like a typical asteroid. Most near-Earth asteroids in its size range fall into a well-known family called S-type asteroids, with a spectral fingerprint scientists have catalogued thousands of times over. Kamoʻoalewa's spectrum didn't cleanly match that family at all. Instead, it looked like moon rock. Specifically, it resembled samples brought back by Apollo missions, weathered by billions of years of space exposure in a way that matched the moon far better than any known asteroid family. That's a strange thing for a normal asteroid to do, and it's the exact kind of anomaly that makes planetary scientists sit up. It led researchers to a specific suspect, a relatively young crater on the moon's far side called Giordano Bruno, about 22 kilometers wide, likely formed within just the last few million years, practically yesterday, in geological terms. The leading theory, an ancient impact blasted a chunk of the moon clean off the surface, and that fragment settled into an orbit around the Sun almost identical to Earth's own, tagging along with us ever since, disguised as an ordinary asteroid. If that's true, Kamoʻoalewa isn't a visitor from the asteroid belt at all. It's a piece of our own moon that's been quietly shadowing us the entire time. Naturally, someone decided the only way to know for sure was to go grab a piece of it and bring it home. China's Tianwen-2 spacecraft launched in May 2025 and spent 13 months crossing space to reach it. On June 7 this year, it fired its engines and settled into orbit alongside Kamoʻoalewa. And right now, this week, it's closing to within about 20 kilometers, close enough to map the surface with cameras, lasers, and radar in detail no one has ever had before. The plan: collect at least 100 grams of surface material, possibly up to a full kilogram, and bring it back to Earth, landing near the same site used for China's crewed spacecraft returns. If everything goes to plan, that sample lands back on Earth in 2027. And then we'll finally know for certain whether we've been sharing our orbit with a piece of our own moon this whole time. This isn't even where Tianwen-2's journey ends. Once the sample capsule is on its way home, the main spacecraft keeps flying, heading toward a rendezvous with a completely different object, a main-belt comet, arriving nearly a decade later in 2035. Kamoʻoalewa is the headline target, but it's really just the first stop on a much longer road trip through the solar system. Here's the part that should really change how you think about the space around us: Kamoʻoalewa isn't alone. Astronomers currently know of 7 quasi-moons quietly looping near Earth, plus an unknown number of even smaller mini-moons that drift in and out of Earth's neighborhood for a few months or years at a time before wandering off again. One of them, called 2025PN7, was only discovered a few months ago, and has apparently been silently accompanying Earth for roughly 60 years without anyone noticing. Another, nicknamed Cardia, has likely been looping near us for centuries. There's an even smaller category called mini-moons, objects that get temporarily grabbed by Earth's gravity for a few months or years, loop around us a handful of times, and then drift back out into their own orbit around the Sun, gone as quietly as they arrived. One, called 2020CD3, was roughly the size of a washing machine and nobody noticed it leaving until it was already gone. And then there's even talk of temporary ghost moons, objects that may swing by so briefly and faintly that we've likely missed most of them entirely. We didn't get a more crowded solar system recently. We just got better telescopes. Earth has probably always had a small, shifting entourage of companions like this. We only started noticing in the last decade, and the rate of discovery is accelerating. Every new generation of sky survey finds fainter, smaller, closer objects than the last one could, which means the honest answer to how many quasi-moons does Earth have isn't 7. It's at least 7, and probably more we simply haven't spotted yet. This isn't just a fun fact. Quasi-moons and mini-moons are some of the easiest objects in the solar system to reach, because they're already moving at nearly the same speed as Earth. Some take less fuel to visit than the moon itself, even though they're much farther away on paper. That makes them realistic targets for future mining missions or crewed test flights, practice runs for deeper space without a deep space budget. They're also a preview of the kind of small, hard-to-spot object that could one day actually be a genuine impact risk, something building-sized, dark, and easy to miss until it's uncomfortably close, so finding and tracking them matters for planetary defense, not just curiosity. And if Kamoʻoalewa really is a chunk of the moon, studying it up close is effectively a way to study a lunar impact crater without ever leaving low Earth orbit. So the next time you look up at the moon, remember, there may be a small piece of it, 40 meters wide, quietly looping along beside Earth right now, invisible to the naked eye, invisible to almost every telescope on the planet, and yet close enough that we've now sent a spacecraft to touch it. It's been out there since before anyone alive today, since before the country that just visited it existed, since before most of human history as we know it, and this week, for the first time, something built by human hands is finally close enough to check what it's really made of. If you want the next video to cover what happens when that sample actually lands back on Earth in 2027, let me know in the comments.